Welcome. So, you ready to jump into the world of data? Well, you've come to the right place. Today, we're diving straight into R, a super powerful tool that's going to be essential on your journey.
All right, so here's the game plan for today. We're going to start with the absolute basics, getting everything set up. Then, we'll talk about a really crucial idea, random sampling. From there, we'll get our hands dirty wrangling and visualizing data. We'll also cover how to get data in and out of R, and wrap things up by looking at how you can build your very own functions.
Okay, first things first. Just like any good craftsperson, a data analyst needs their tools. So before we can do any cool analysis, we've got to get our R workshop set up with all the right gear.
Think of this line of code right here as your one-time trip to the hardware store. Seriously, you only have to do this once. You're installing 3 essential toolkits, or what R calls packages. You've got Tidyverse, which is amazing for manipulating and visualizing data, then Survey for, you guessed it, survey analysis, and SDAR resources, which has some data sets we're going to play with. Just run this command once on your computer, and you're all set.
Now, just because you bought the tools doesn't mean they're out on your workbench, right? That's what Library does. At the start of every single R session, you've got to tell R which tools you're using today. It's like saying, okay, for this project, I need to grab my Tidyverse tools and my survey tools off the shelf. This command loads them into your session so they're ready to go.
All right, let's talk about something that is absolutely critical in good data science, reproducibility. This is a big deal. It means that if you share your code with someone, they should be able to run it and get the exact same results you did. It's what makes science verifiable. But wait, how does that work with randomness? Let's find out.
So here's the secret sauce, the set.seed function. You see, computers are actually terrible at being truly random. They generate what we call pseudo-random numbers, which are sequences that look random but are actually deterministic. They start from an initial value, which we call a seed. By setting that seed to a specific number, like 42 here, we're telling the random number generator exactly where to start. So when we ask for 3 random numbers with renif3, we get this very specific sequence.
And check this out. This is the magic moment. If we run that exact same code again, resetting the seed to 42 before asking for the random numbers, bam, we get the identical sequence back. This isn't a mistake, it's a feature. This is the whole foundation of reproducibility in action. It guarantees that any random sampling you do can be perfectly replicated by anyone else.
But what happens if we don't reset the seed? Well, if we just ask for 3 more random numbers, the generator just keeps going from where it left off. See? A completely new set of numbers. So the key takeaway here is super important. If you want reproducible results, you have to set your seed right before the code that does the random stuff.
And this whole idea applies directly to sampling from data. The sample function is incredibly useful. In this first example, we're basically simulating flipping a coin 4 times. We have to set replace to true because you can get heads more than once, right? Same for the next one. Rolling a 6-sided die 4 times. You can roll the same number again. But in the last one, we're drawing lottery numbers. Once a number is picked, it can't be picked again. That's why we set replace to false.
Okay, now that we've got those ground rules down, it's time to roll up our sleeves and actually start shaping some data. We're going to learn the verbs of data manipulation using an incredibly powerful package called dplyr, which is part of the Tidyverse.
So the first thing you'll notice when you're working in the Tidyverse is this thing called a tibble. What is it? Well, think of a normal R data frame like a messy stack of papers. If you try to look at it, it just dumps everything on your screen, which can be thousands of rows. A tibble, on the other hand, is like a well-organized binder. It's much smarter. It only shows you the first few rows, tells you what kind of data is in each column, and never overwhelms your screen.
Okay, get ready, because this little symbol is about to become your new best friend in R. It's the pipe operator. Basically, it lets you read your code like a sentence. You can say, take this data, then do this, then do that. It's a game changer for making your code clean, readable, and logical. You just chain your steps together one after another.
And here's a perfect example of that power in action. Let's say we have some student data. We can build a whole data processing assembly line. We start with student data, then pipe it into select to grab only the score in class columns. Then we pipe that result into filter to keep only the students from class 1. And finally then, we pipe that into arrange to sort the results by score, from highest to lowest. See how it just flows?
Next up is mutate. This is your go-to verb for creating new columns. It's super powerful. For instance, we could take a column of numeric scores and use mutate to create a brand new grade column with A, B, C, and so on. Or maybe a pass-fail column. It lets you create new information based on the data you already have, right on the fly. Now this is where things get really cool. When you combine group by and summarize, it's a 1-2 punch for getting insights. First, you use group by to split your data into groups. Imagine sorting a deck of cards by suit. Here, we could group our students by their class. Then, you use summarize to calculate statistics for each of those groups. So in just a couple of lines, you can find the average score, the number of students, whatever you want for class 1, class 2, and so on, all at once.
All right, we've sliced and diced and summarized our data. Now it's time for the grand finale, turning those numbers into something we can actually see. Let's make some beautiful and insightful charts using ggplot2, which is the package for data visualization in R.
So let's break down how ggplot works. It's built on something called the grammar of graphics, which basically means you build plots layer by layer. The first line, ggplot.creates, a blank canvas and tells it what data to use. Then, inside the AS, that stands for aesthetics, you map your data to visual properties. Here, we're mapping the score variable to the x-axis. After that, you just add layers with a plus sign. Geom_histogram is a geometry layer. It tells ggplot how to draw the data, in this case, as a histogram. And finally, we can add another layer, labzo, to add a title. See, layer by layer. And we can use that exact same layered logic to create even more useful plots. For this box plot, our aesthetic mapping is a bit more complex. We're mapping class to the x-axis, score to the y-axis, and we're mapping class to the fill aesthetic. That's what's going to give each box a different color. Then we just swap out the geometry layer. Instead of geom_histogram, we use geom_boxplot. And just like that, we have an amazing side-by-side comparison of the scores for each class. Okay, so you've done all this great work, but it's not really done until you can get data in and get your results out. A huge part of being a data analyst is knowing how to handle data from different sources and how to share your work. Let's cover the basics. R is super flexible when it comes to loading data. You've got a few common ways to do it. Sometimes data actually comes bundled inside a package, like the datasets we're using. You can also pull data directly from a website using a function like read.table. And of course, probably the most common way is just loading a file, like a good old CSV, straight from a folder on your computer. And just as important is saving your progress. Once you've cleaned up your data or calculated some summary stats, you'll want to save it. You can use write_csv to save a data frame into a simple CSV file that pretty much any program can open. Or if you have a more complex R object, like a statistical model, you can use save_rds. This saves it in a special R format that perfectly preserves everything so you can load it back up in your next session. As you get better and better at R, you'll find yourself doing the same tasks over and over again. That's the perfect time to start building your own tools by writing functions. But there's a right way, an R way, to do it that's way more efficient. This slide really gets to the heart of how R is designed to think. On the right, you see a for loop. If you've programmed in other languages, this probably looks familiar. It goes through each element one by one. And yeah, it works, but it's kind of clunky and long. Now look at the left. That is the R way. R is built for something called vectorization, which just means its operations are designed to work on entire lists or vectors of numbers all at once. We can just write x plus y, and R is smart enough to handle the element-by-element addition behind the scenes. It's not just cleaner to read, it's also way faster. So we've really covered the essentials today. We went from setting up your toolkit and understanding reproducibility, all the way to wrangling, visualizing, and even creating your own functions. You now have the fundamental skills of a data apprentice. The tools are on your workbench, so now it's your turn. It's time to get out there and uncover the stories that are waiting in the data.